My name is Chris Curry. I'm part of the Bacchus.
My name is Esteban. I'm part of the Bacchus.
I'm Carla Scott, and I'm part of the Bacchus.
The challenge for this competition is that we have to design a robot that can put 4 rings on the stick, stack 4 rings, and locate a color strip of paper.
So to explore the task of placing and moving the rings, we had to come up with a robot that can pick stuff up, move around in each direction, and place stuff down.
My name is Carson. I'm the lead driver of our team, the Bacchus. And today I'll be talking about the indirect side design. So to begin with, we wanted to do an omni-drive based design. So we wanted to do an hexagon side. We can have just the sides for the wheels. But then we realized that would be really hard to make the shape with the angles and whatnot, make it all even. So then we decided to reduce it to a square. But then we came upon the same problems again. And it just looked funky. And we didn't have enough wheels and motors to use 4 to make the omni-drive. And so then we decided to reduce design once more to a triangle. So I only had to use 3 wheels and 3 motors. So then once we came up with that design, we made a flat base and we added a little I-beam across so we could hook on the main panel on the back, whatever that thing's called. And then after that, we put it on stilts so it was a little bit higher than the rest. Then we had originally put the motor on the front. But we came to the problem that when we were driving and we would stop, the robot would tilt forward or the cloud would make the robot shift. So we decided to take it all off and we put this little angle piece on the front of the robot, and we might do it for all sides. So when it tilts over, it's blocked by the tilting thing. And then we're also rebuilding the claw and the design to hold the main computer component. So we're probably gonna make it lower so we have a lower center of mass so it doesn't tilt over as much. So yeah, that's what we have.
Robots are used in everyday life, and some ways that they are used in today is in the medical field, the military, and school.
The challenges of manufacturing, motion control, material selection, human-robot interaction is essentially to unlock the potential of robotic systems, and that's used for mechanical engineering. In robotics, we learn how to wire and manufacture robots, which could get you a job in electrical engineering. Robotics construction represents a paradigm of shift in the way structures are designed, planned, and executed, and that's a civil engineering major.
So for the functionality of the robot, we have it so when the joystick is pressed this way, it goes forward. When it's go the other way, it goes backwards. When it's go this way, it goes sideways, and this one goes also sideways. We have it so if this one goes this way, it spins that way. If it goes this way, it spins that way. On this joystick. We have it so when you press this, it goes up, and it can close right here. Open and close, and it can go down as well. Also, we have it so when we press A, it goes into autonomous mode. And then when we press B, it gets out of autonomous mode.
The controller's third axis is pushed forward. The 2 front wheels of the robot will move forward, and when the third axis of the wheel or the joystick is moved backwards, the 2 front wheels will move backwards.
Gear 1 equals 5. It spins closer, and we have to wait 3 seconds.
If button R1 is pressed and the robot's claw, it's gonna open. But if you press button R2, then the claw's gonna go forward and close.
This code right here, if the left one button is pressed, it will make the motor A, which is the motor that is connected right here, spin in reverse, which will make the arm go up. If you press the button L2, which is on the same side, it'll cause the motor to spin forward, which will lower the arm.
So for the code right here, it has it so when started, if the axis on this controller right here reaches here or here, it's able to spin these motors to make it in the position with the omnidirectional. So it goes left or right. So when the controller in the 4th axis right here is over here in this position, it spins it left, and it's here, spins it right. That's it.